Hi everyone, I'm Nelson, one of the students under Dr. Hadi supervision for FRRP1 in this semester. My FRRP topic is development of an integrated structure for hydrogen production system using photovoltaic panels and electrolyzer. Case Study Malaysia. For introduction, the use of solar energy to supply power for hydrogen production through water electrolysis is highly recommended for clean future industry and sustainability of environment. Problem statement. In current era, fossil fuels are decreasing rapidly as most of the load demand in the world still rely on them. Hydrogen can be one of the alternative carbon-free energy source to replace the limited source of fossil fuels. Currently, there are limited studies on implementation of hydrogen production system with PV panels and electrolyzer in Malaysia. The objective of this FYRP topic includes to undertake a critical review on hydrogen production system with PV panels and electrolyzer to be implemented in Malaysia, to design array of PV panel based on Malaysian weather to generate power for electrolyzer, to develop and analyze electrolyzer for producing hydrogen through water electrolysis, and to evaluate the solar to hydrogen STH efficiency of the proposing hydrogen production system in Malaysia. For literature review, the main components of the hydrogen production system basically consist of solar energy, PV panels, and electrolyzer. There are basically two types of PV panels, which are lower efficiency conventional types and higher efficiency concentrated types. It is decided to implement the conventional type PV panels, such as monocrystalline or polycrystalline panels in this FYRP, as the concentrated types are still not available in the market. The current electrolyzer available in the market are alkaline electrolyzer and proton exchange membrane electrolyzer, or PEM for short. As shown in this table, both the operating temperature are quite similar, but they both have different advantages and disadvantages. After comparing the electrolyzers, it is decided to implement the PEM electrolyzer in this FRRP as the advantages outweighs the disadvantages as compared to the alkaline electrolyzer. There are two methods of connecting the PV panels to the electrolyzer, which are direct coupling and coupling through DC to DC converter. After comparing the pros and cons of the connection methods, the direct coupling method is chosen to be implemented for FRRP, as higher production efficiency can be achieved, and the time needed for implementing this method is shorter, which is suitable for the FRRP, as the time given is limited. For the methodology of this FRRP topic, the flowchart of the methodology is given in this figure 1. Collection of essential data, such as selecting desired location in Malaysia, load demand of hydrogen production system, and period of interest will be the first to be done. Next is the development of solar radiation model to collect the global solar radiation data on horizontal and fixed surfaces, which this is done in MATLAB coding. After that is selecting model of PV panel and PEM electrolyzer cell stack for developing the simulation models. After the selection of PV panel model, a simulation model of PV panel, shown in figure 2 right here, is developed to use the global solar radiation data to determine the power generation per panel, as well as the voltage and current of the panel at maximum power point, or MPP for short. Calculation is then done to identify the number of PV panels that needed to be connected in series and parallel for fulfilling the power demand. A simulation model of PV panel is then developed in MATLAB Simulink, as shown in figure 3, based on the calculated number of PV panels to be connected in series and parallel for supplying power to the PV and electrolyzer. Another calculation is done to determine the number of PEM electrolyzer cell stack required, as well as the current input time to the PEM electrolyzer for the hydrogen production. The simulation model of the PEM electrolyzer is then developed in MATLAB Simulink, shown in figure 4 right here, based on the calculated values. The simulation model of the PV system and PEM electrolyzer are then direct coupled for producing hydrogen in interested time period. Data collection and performance evaluation will then be done, and the results will be validated through comparing with other research articles. As for preliminary result in FRRP1, the results of the solar global radiation falls on horizontal and tilt surfaces in a year are given in this figure. The average annual data of global solar radiation force on horizontal surface is used as the solar radiation input of the developed simulation model of PV system. The simulation model of hydrogen production system is shown in this figure. The amount of hydrogen produced from the hydrogen production system with consuming 100 megawatt in a year is around 1.123 times 10 to the power of 10 meter cube per annum. As the simulation models developed in MATLAB Simulink can only take one input and display one output. The preliminary results are in terms of average value in a year, which the result of 10 cannot be used for performance evaluation for the developed hydrogen production system. In future works, the simulation models for hydrogen production system will be fully developed through MATLAB coding, which the output of the simulation models will be in hourly basis, so that the performance evaluation of hydrogen production system can be conducted and the results obtained will then be validated through comparing with other research articles. And that's all from me. Thank you.